I mentioned earlier, I'm a physical scientist with NESDIS here in Fort Collins. I do a lot of work with imagery, including RGBs. I also interact a lot with the users, like Carl, and I try to do a lot of work capturing user applications, satellite imagery, and sharing them broadly with the rest of the user community so that we could all learn from each other. Before this position, I was a forecaster with the National Weather Service in Pueblo, Colorado, so serving southern and southeast Colorado. Very humbling experience forecasting for elevations from 3,000 feet above sea level to 14,000 feet above sea level. So you can imagine how difficult that makes forecasting. So I'm going to try to bring that experience as a forecaster and now as a researcher into this presentation. I'm going to throw a lot at you, so if anything piques your interest, you want to talk about it more this week, please jot it down, and we've got all week, or you can always email me and we could chat after this meeting. So I'm going to talk about kind of three main topics. My perspective on current usage of RGBs and National Weather Service WFOs. Then I want to talk about some of the new and future RGBs that I've developed mostly in collaboration with Weather Forecast Offices, and then some additional RGB thoughts. So my perspective on current use of RGBs across the Weather Service, and this is based on my experiences, myself as a forecaster, my interactions with forecasters, but also I have scripts that run area forecast discussion analytics. Forecasters write text discussions multiple times a day, and I scour those discussions for satellite references. I know others have done that as well. And I just did 2021 quick, and there were about 500 RGB references in 2021. But looking at specific RGBs, nighttime microphysics had over 600 references. So forecasters aren't always saying nighttime microphysics RGB. They might say nighttime microphysics product, et cetera. But it was nice to see Carl's, statistics matching up pretty much with what I found. Nighttime microphysics and day cloud phase distinction are really the bread and butter RGBs across the Weather Service for cloud analysis during the day and night. But as I'll show, these products have other applications as well that we're seeing forecasters use. GeoColor also widely used, not just for aerosol analysis, smoke, dust, but also it's visually pleasing. The public understands GeoColor, it's true color imagery, so you see forecasters sharing it on social media quite a bit. And then situationally, definitely a lot of usage of the Visire sandwich and dust RGB from what I've seen. So again, a lot of examples. This is a funny example, just an experience of how some forecasters are slower to latch on to new technology than others. I had a forecaster come up to me this early 2019. Hey Bill, look at this example. You can't see the low clouds around Colorado Springs in the Viz, but you could see it in the RGB. Well, this is an example, that I've shown you many times over the last year, but finally latching on and just showing you that, some forecasters, the old curmudgeons, are stuck in their ways, but eventually seeing the benefit of a new product over time, it's going to help. And in this case, analyzing low clouds and fog around the Colorado Springs area helped the forecaster in completing their TAF where you had those clouds over snow. Sorry, right here. So in this, on the left, you can't, really differentiate the low clouds from the snow, but on the right, you can see where those low clouds are. But also in the high mountain valleys, look on the left, no way you're gonna differentiate low clouds from snow in the single band Viz, but this could be valuable in making your temperature forecasts grids for the day, knowing where those low clouds are within the high mountain valleys there. But there are other usages of this RGB. The start of this presentation is the day cloud phase distinction love fest. I'm sorry. Snow squalls. Maybe you're in an area where you have a radar down, or you have snow falling below the radar beam, so you're not capturing it within the radar. There's been a lot of great cases, comparing day cloud phase distinction with MRMS composite reflectivity. The RGB really highlights those snow squalls where you have glaciated cloud tops really well. So I think, and I know Dan, you've worked on some training looking at this as well. So hopefully offices are picking up on this application. Of course, convective initiation, see a lot of this, especially this last summer forecasters leveraging day cloud phase for convective initiation. This was a case over Texas across the southern high plains. Early on, just monitoring the Q field hours before convective initiation, you start to see areas that, texturally you'd be able to see in the viz, the clumping together, but you also start to see the change in the cloud top phase from those cyans to more greens or yellows as you start to glaciate. And then eventually you start to see more widespread glaciation and orphan anvils, like in this case around this area, telling a forecaster, well, we're within probably half an hour of convective initiation. And then moving forward in time, you see successful convective initiation. This was an interesting application over Southeast Colorado, frost. And we issue obviously frost advisories in the Weather Service, but to know where, or help you on your verification of where you had frost actually occur for this day, you could see the frost that was underneath the low stratus deck. As that stratus erodes, you could see where frost had developed early that morning. And then hail swaths. This is really important. And I'm thinking an application of how a forecaster would use day cloud phase distinction to diagnose a hail swath. You can see it here. Maybe you have a strong thunderstorm moving towards an interstate over a rural area, and you're not getting reports of that accumulating hail, but you see that it's approaching an interstate. You might contact your emergency manager and say, we've got accumulating hail, likely maybe on the order of inches to half a foot approaching the interstate. And that would lead them to direct resources towards that region, snow plows, et cetera. And we see that in Colorado, snow plows coming out to plow up the accumulating hail, usually small hail. Moving out of my love fest towards the nighttime microphysics RGB, obviously for low clouds and fog. And again, this and day cloud phase, these really forecasters latched onto these in general pretty quick because it was obvious the value that they were providing over their currently used data sets with the previous GOES data. For example, for fog at night, generally forecasters would be using the shortwave IR window difference to differentiate liquid water from ice cloud tops. But with nighttime micro, they could further differentiate those clouds into more likely fog or your lowest clouds that are liquid water to your more mid-level water clouds that are also liquid. And then for ice clouds, your thicker ice clouds versus your thinner ice clouds. And just an example using nighttime microphysics in the Bismarck, North Dakota CWA to issue a special weather statement for this case of fog developing across southwest North Dakota. But applications of nighttime microphysics outside of just your simple low cloud analysis, and Kevin from SPC has been working on this, applications of nighttime microphysics. In this case, you could see a retreating dry line and a progressive cold front here. You could actually see the different air masses ahead of and behind these boundaries. So you could see the boundary movement between the observations, and then you could see where they're colliding. You start to see clouds develop, water clouds at first, but over time you see the change in the microphysics as that convection develops. Eventually you see the red start to develop as those clouds glaciate, and then you get convective initiation. So similar application at night of the nighttime microphysics to during the day with the day cloud phase. And then of course, VisIR sandwich. We did get a VisIR sandwich RGB implemented into AWIPS, but I think a lot of forecasters still like to just do the manual overlaying of semi-transparent IR on the viz because you're still able to, in our software, I think it's important, forecasters like to be able to sample the imagery and get readout of what are those cloud top brightness temperatures, in addition to getting that texture information from the viz. And then blowing dust. Especially this last spring, a very busy blowing dust season. This was an example of Aviation Weather Center forecaster basically shaping his polygon based off of satellite imagery for an IFR SIGMET. So AWC leveraging the dust RGB. And then in a weather forecast office, a forecaster issuing a dust storm warning polygon based off of the dust RGB imagery. And then I mentioned geocolor as well, valuable for blowing dust and smoke diagnosis, as well as use on social media just to communicate general meteorological situation. And I do want to mention that RGBs, it's incredible. You see a lot of forecast offices posting RGBs, including some of the more complex ones, such as dust RGB or nighttime microphysics, on social media, and highlighting, annotating these images to try to communicate to the public, what are these RGBs telling us about the meteorological situation. So bringing that science into decision support services, it's pretty neat to see. All right, now on to some more fun stuff. This list really grew fast. I'm gonna try to go through it quick, but these are just things I've worked on over the years, mostly in collaboration with forecasters wanting to solve an issue, and I worked with them. And so I guess for the most part, all of these have been shared probably low key with various offices that wanted them. So we've talked about dust RGBs. I know for color deficiency folks, dust RGBs, it's very difficult to analyze dust. I'm actually colorblind, yet I work a lot on RGBs. Isn't that funny? So I did a satellite book club webinar on dust detection, and I developed this dust alternate RGB, basically similar to with air mass. I just swapped the red and the green components. Katie, have you done dust RGB?
We're trying to get the air mass RGB into AWIPS. We're looking at this as well.
And the feedback on this was that people without color vision issues found that this one on the right, it was more easy to diagnose the dust, which is this color. A lot more contrast in this version on the right than on the left, maybe even for folks without color vision issues. And then I had some requests for, now, when we have high winds across the southern plains, you're going to get dust, but you're also going to have a critical fire weather condition. So can we have an IR-based product day-night that can detect dust and fires? So I put this together. You could see the fire hotspots as red, and then the dust is this shade of green from the day into the night. That seems to work pretty well. You could also differentiate various cloud layers also, and this was shared by a couple Western offices. Curtis is going to talk about this more, but I don't know if anyone uses the day land cloud fire RGB, that's ABI, but I know the VIIRS version of this RGB in Alaska uses the 3.9 micron channel instead of 2.2 for your red band, and I think we should switch the version that's in AWIPS, replace the red component with from 2.2 to 3.9 so that you could get imagery like this. You could see the hot spot, you could see the smoke plume, and you could see the burn scar. And I think this RGB would be leveraged a lot more if we made that switch. And I think, Curtis, you call it the natural fire color RGB. And then snowmelt RGB that Curtis developed. There's the VIIRS version on the right. Carl talked about this, being able to assess blowability of the snowpack, but also in flash flood situations, the lighter shades of blue are fresher snow, so increased blowability. I tried to simulate this. I think this is what you had, right, as the melting snow RGB, trying to simulate, what you're getting from VIIRS with ABI. Could kind of get there. Maybe if I tweaked it more, it might look a little better, but you can still tell the differences in the snowpack here. I'm not going to go into too much detail here. Carl already covered it, I think, with this example, but making those simple tweaks to the day snow fog RGB, sorry, this label's wrong, but this was the blowing snow RGB we created. Again, another example of collaborating with a forecaster to address a forecast need with an RGB, simply replacing the red component with the high resolution viz and modifications to the thresholds. And we also did it with VIIRS, so you could get that higher spatial resolution from VIIRS, 375 meters. And sea spray RGB, this was an example working with Anchorage and Juneau, Alaska forecasters. Sea spray is a big problem up there, specifically freezing sea spray. It'll sink a ship, and people have died from sea spray freezing onto ships and sinking them, as was shown in, I think, Yvonne's presentation. You can see it in true color imagery, but we wanted to really highlight the feature and differentiate it from other features, low reflectance signatures, such as turbid waters you can see here, and not in this example, but glacial silt is something that looks similar to sea spray as well. So we spent quite a bit of time really trying to perfect this RGB to highlight sea spray, and maybe it could be better, but I think we did a pretty good job here. The viewers on the right, you can see the sea spray coming out of Cook Inlet in the Gulf of Alaska. And then there's a ABI version on the left, and we have a publication on this. You could certainly read in your leisure. And then the idea of additional geocolor layers, Steve Miller works on this, but we want to, again, the point of all this is to condense a lot of information into like one useful image that forecasters could use, but it still needs to be intuitive. So can we take geocolor? Can we take a dust layer to highlight dust as yellow? Can we imprint a fire hotspot layer? You could see these red hotspots popping up so that a forecaster could look at one screen to do their forecasting analysis. A couple more leveraging of day-night band and RGBs. I think something we could look at. It's actually a part of the nighttime Veers geocolor RGB, but there's probably some more maybe with low clouds we could do with day-night band from Veers. And then last example from this section, RGBs with GLM. I haven't really seen it. I've heard people talk about wanting to do it, but I haven't seen it. This is one I made just combining the minimum flash area with flash extent density to give you an idea of where you have many small flashes versus, which is yellow, versus a few small flashes, which is red, versus large flashes, blue. So I think we could do some more work there. All right, a couple more topics. Dynamic RGB thresholds. I think some people have looked at this, but can we extend the use of like day cloud phase distinction towards sunset or sunrise so that it looks like on the right, more consistent, maybe you get an hour more towards sunset versus on the left where you're losing your solar reflectance. So this is just a mock-up I did on the right. You can see you get an extra hour to 2 hours. And then we talk about RGB modifications. Yeah, if you're a forecaster that wants to use day cloud phase distinction to analyze mature convection, it's simple to just adjust the max threshold for the solar components so that you can see the cloud top details. And this comes when we talk about responsible RGB modifications. What can a forecaster do quickly on the fly to not really change the meaning too much of the RGB, but for a situational purposes. And then just an example over Alaska, making modifications to the RGB to make it appear more what they might be useful or used to from a quick guide or from a difference from the summer. And here, this is an example of nighttime microphysics RGB, same day, same time over Pennsylvania for low clouds and fog versus over Texas. I mean, they look totally different. Forecasts are getting good at, understanding the differences in season, but again, another example of how we could make simple modifications to that RGB to make it look a little more close to what they're used to. I'm very close to being done. This is just an example. One of my colleagues in Canada, who we should have invited, I forgot to mention that, talks about how they have displays that combine nighttime microphysics with day cloud phase distinction, just combine RGBs that are showing the same thing day and night. I think it's just something that would be helpful and useful for a user. Oh, last topic, very important. We should, this is the idea of combining quantitative information from our derived or level 2 products that show what is the cloud top phase, what's the cloud top height quantitatively, combining that information with our RGBs. So for example, day cloud phase distinction RGB in AWIPS, you could sample information. What if I sample this cloud and it tells me that the phase is ice and that the cloud top height is 24,000? I remember, oh yeah, that color means that it's glaciated. It's an ice cloud and it's pretty tall. We actually did recently implement this into the National Weather Service AWIPS, and I hope that it gains traction because it helps with the, users' understanding of the RGB, but it also gets those very useful quantitative level 2 products used. So we did it with quite a bit of RGBs. There's the list. And then you could look at this, and if you have ideas for other combinations, we could certainly add those. And that is all. Thank you.
Well, let's take a couple minutes for questions.
First of all, Bill, your stuff is always stunning.
Thank you.
So I had a really neat, I had an experience last couple of weeks down in Florida. One thing that I learned is motorboaters have cell phones, and they whip their cell phones out and they look at radar. They actually look at the blobs going by, and they interpret. They're like their own little forecasters, you know, and they figure out what they're going to do, and they actually look at these radar displays going by. And I look at some of the displays, that these RGB animations, and I wonder, and I guess really this is more for maybe Jordan or Dan, or so, why can't we get, now that our resolution is down to 2 kilometer, half kilometer, we're in the game with the radars in terms of temporal update, in terms of all that stuff. Why can't we get that on the phone?
There hasn't been a great app. I know there are a few out there that are pretty good, but I think someone just needs to develop, a phone app.
Okay,
We could do it, yeah.
So, because they're not reading the forecasts, they're looking at the, you know, I had several experiences where people were pulling out their apps, looking at the displays and making decisions of what they were going to do, where they were going to drive their boat, that kind of stuff. Second question, you know, we're spending a lot of time talking about the spectral combinations and so forth. One thing I noticed with your stuff, the animations, you play with time compression ratio quite a bit. Sometimes you speed it up, sometimes you slow it down. And is equally important? You know, how important is getting the right time compression ratio to teasing out the feature that you want seen in the animation?
I think it's important. Yeah, that's always been a big thing for me, especially with 1 minute imagery, very fast animations, because, you know, an animation adds another dimension, you know, to the product that you're seeing that you're not seeing with the still images. And I guess that's not really something we harp on too much in forecaster training, the importance of animation, but I think that's a good point.
And this is Bernie. I'll add a comment about animations too. I've discovered I have some motion vertigo. And so if you see me diverting away from some of the animations, it's because I don't want to get sick. So, and I found that something like 40% of all adults over the age of 40 may have some sort of vertigo. So keep that in mind when you're throwing down animations to people too.
Okay, this is Jose here. I'll try to be short. Excellent presentation. There's a lot of stuff that, and trying to be in the context of what we're speaking about, visualization of things, which is also a challenge, because we all, as you know, we'll be discussing, perceive things differently, and some people have, different ways to see things. Whenever you generate an RGB, there is different ways that you can adjust the different channels in order to generate it. So usually what we use is you narrow down the temperature ranges or the reflectivity ranges, and you have the gamma, right? And that way you kind of tune it up to show what you want to show. And then you can do things like what you can mention, you flip, the red with the green, and see, oh, maybe this looks better, and maybe we can use this. So my question is, have you ever tried to adjust the contrast after the fact? Once you got like the final product, have you ever played with, a final adjustment of the contrast of the final product and see how that can improve?
No.
I don't know if that's allowed.
You can't really do that in AWIPS, which AWIPS is the software Weather Service uses. The gamma. But that's not necessarily purely contrast, though. That would be gamma, but from what I understand, he's saying is more
Well, after the fact, because you can, well, before
Like
the
a
fact,
television changing the contrast.
right, like before the fact, you play with the gamma and you play with the temperature ranges. So maybe, I mean, you can narrow down to do it that way, but I wonder, sometimes when you get the final product, and if you go to just this very simple, whatever software you have, and play with the contrast or some other features, you can really highlight some features in the RGB and much better just by doing these after the fact calculations. So something to think about. But and of course, I mean, if you play with that, we need to find a way to make it standard because it's an extra calculation. We don't want to overcomplicate. But yeah, I think it could be applicable for things, for example, like dust. You guys found, I mean, there's great ways to show it, and I really like your presentation when you show that standardization and the calibration and the limb correction and stuff like that. Try to standardize. But I'm sure there are other ways if you want to highlight one particular feature in an RGB that maybe you can do this post-processing on top of the RGB without complicating it too much, and just to highlight that feature, just as a thought for future development. I don't know.
Thanks.
All right, Bodo online and then Scott online. Go ahead, Bodo.
Okay, just in terms of speeding up the animation, from a forecaster's perspective, I've actually co-authored a paper with some of my bureau colleagues where we basically asked half of our bureau forecasters about that. And what they favor doing is at the start of the shift, they'll do a 10 frame per second, followed by a 2 frame per second for familiarization. And then during the shift, they'll generally do 2 frames per second because the 10 frames per second is just simply it really impacts on you too much. But they'll switch it back over onto the 10 frames per second whenever an unexpected development, say thunderstorms, are starting to happen. And so they're often able to detect the triggers that way. So that was just one point about how the different animation speeds are used during the forecasting session. The second one was Bernie mentioned about the butcher effect, where you're basically animating things very quickly and people can get ill. I've generally found that's more a case where you're flickering images rather than when you're playing a movie through. That's from my own experience. Thank you.
I think maybe it varies from user to user and animation speeds and whatnot. I really like to make them go fast, but this discussion, I think, is telling me that it does vary. I don't know what the best thing to do is, though. Scott?
I can read Scott's question. He may be having trouble with audio. The question is, could the AWIP's default be changed to load the level 2 information underneath versus having to find a separate menu for it?
Yeah, when you load an RGB, have it load the L2 product information underneath automatically. Yeah, I mean, we could also just change the menu item to do that. But yeah, there are ways. Yeah, Scott, there are ways to. That's basically what we did, except we added a different menu item so that forecasters could have the option to choose between them.
All right, one more, and then we'll take a break. Emily.
Yeah, so how do you account for some of the potential error with the level 2 products? So what if somebody thinks that the level 2 product says it's a low cloud and it matches up with a certain color RGB? Have you found kind of those null instances where it's worked really great and other times where it's like, that looks different?
Yeah, definitely. I think a lot of examples where I would say the L2 product's probably wrong, based on if you're interpreting the imagery right. And that's something that we communicated, when we put this out, that, they might not match up and you have to use your expertise as a forecaster and image interpreter to make the best decision. So it's really a supplement here.